Hello, everyone. Thank you, Chris. I've been working with Islandora for almost 10 years now, and I have close to 20 years experience in system administration and IT operations. I have a great interest in Amazon. You can see a few of the certification exams that I've written there. I'd recommend anybody who really wants to get into Amazon to maybe start off with a cloud practitioner exam. I found going through it and studying it really helped give me a broader understanding of all the different Amazon services that are available. One thing is they're always adding more. So to try to keep on top of it, I try to write one a year if I can. And I find it quite helpful in keeping up with all the different services. So what I'm going to do is I'm going to walk you through some common services that we use at DGI, and I'll try to end the discussion with an overview of our S3 storage setup that we use with Islandora 8, and as well as a proof of concept high availability Islandora 8 stack that I had set up and tested. Due to time constraints, I won't be able to cover all Amazon services because there's probably 100 of them by now. So I'll try to focus on a few that I think will be most useful to the broadest audience. To start off, I'd like to talk about AWS Organizations. So at Discovery Garden, we have a lot of Amazon accounts, 23 actually. So to try to manage multiple accounts without any sort of structure is very difficult. To help us in this regard, we make use of Amazon Organizations, which allows us to easily create and manage accounts. What we do is we have a centralized administrative account where we have our logging and we aggregate our billing and a lot of system tracking and logging information. We have it go to the central account, and it makes it really easy to track what's going on across the organization. Another thing I want to point out is it's really important that if you're doing development, you should try to do so in a completely separate Amazon account. So for us, we actually have a separate developer account that our developers have access to, and we prevent them from actually getting into any production account through Amazon. Some other things you should consider with working with multiple accounts is using cost allocation tags. So you can set those up in Cost Explorer in the central account. And then it will actually track your billing across all of your different accounts. You may ask why we use separate accounts. In some cases, it's within the contract of the client we're dealing with. And in other cases, it makes it easier to separate certain services and to have a security boundary around certain accounts. Certain things you can do with Amazon or AWS Organizations is implement what are called service control policies. That it's a type of organization policy that you could use to restrict what people can do in each account. So let's say you have a developer account. You could restrict the developers from carrying out certain tasks that you may not want them to, even though they may have, let's say, administrator access to that account. I usually prefer using what are called IAM policies to basically define what people can and cannot do in accounts, but we'll be getting to that in a little bit. If you do plan on setting up multiple Amazon accounts and using AWS Organizations, you may also want to check out AWS Control Tower, which allows you to set up some landing pages and templates to help you create additional accounts. And for us, we actually have our accounts templated in what's called CloudFormation. So we'll talk about that in a little bit as well. So I mentioned IAM. So I actually want to talk about AWS SSO, but they relabeled it. That's something else you see with Amazon. A lot of times they'll combine services or they'll relabel existing services, which kind of confuses things. So what I'm actually talking about AWS SSO, but they've relabeled it AWS IAM Identity Center, which basically combines where you can manage all your identity services. So with AWS SSO, it made it really easy for us to set up an IDP. So to basically centralize our authentication services across multiple things, not only Amazon accounts. So it can provide auth to any SAML-based applications, and it gives you centralized account control, permission control. And what's really awesome about it is that when you sign into it, it gives you a splash page that actually lists all the accounts you have access to. And with this, you could set up profiles on your desktop if you're like a developer, and you could use SSO to sign into Amazon and do control services using the CLI without actually to create like keys or anything like that. Normally recommend not using keys where possible. It's not always possible, but if it is, you should always attempt to use AWS roles over keys if possible, because the AWS roles basically assigns a role. It could be to a person or a machine or a type of service you're using. You can assign a role to it and then define permissions around that. And it's a lot better versus keys, which anybody could take and use. So I recommend that where possible. Something else we use SSO with is the AWS VPN Client. So at DGI, this year after COVID, we were all working remote, like I'm sure a lot of people were. And we were trying to decide when to bring people back. And we ended up doing a poll across the staff, and a lot of people decided that they would prefer to just keep working from home. So what we actually did was close our physical office, and we moved anything that we had left in our office into Amazon. So with that, we also had to figure out secure remote connectivity. So what we did is set up the AWS VPN client, and it basically gives us access to our private VPCs. VPC, just for reference, stands for Virtual Private Cloud. You'll see that referenced across most cloud providers use that term. So it gives us access to our private VPCs. We use that to get access to various internal resources that we don't want to expose to the internet, or to access our client servers through like secure connectivity. We also use it to so we can still have an actual elastic IP or static IP. Quite a few organizations still ask that you provide an IP address if they want to open their firewall rules, so you can log into their server. Some organizations still ask for that. So in doing this, it still gave us a way to have a static IP address without actually having an office with an internet connection. So the client's based on OpenVPN. Our devs, again, operate out of a separate dev account. Developers actually made a tool for it called Box. He built it with Go, and it has seamless integration with SSO profiles, so people they use it to spin up boxes within the cloud. The tool is more built around what we do in-house, around some of how we currently spin up boxes. And it's still being worked on, but one thing he's recently done is he added integration with AWS EventBridge. So when developers are working on systems, so it doesn't cost us a lot of money, EventBridge will actually do shutdowns of the developer boxes overnight. And if they don't want that to happen, there's like a tagging mechanism with it that the developers can specify a tag so that their box won't get shut down if they're doing something like running a long-running test on a migration, for example. AWS EC2, this is where anybody who's used Amazon, most people are familiar with EC2. That's where you spin up servers and things of that nature. I don't want to spend a whole lot of time here because anybody who uses Amazon, this is one of the first places you'll likely stop. A few things I'd like to bring up is that use it to manage a lot of things, not just the instances. For example, you could use it to set up security groups. Security groups is how you open and close ports to get to different systems. You can use it to set up load balancers, auto scaling groups, and load balancers are a way that you can balance traffic between multiple services or systems. And auto scaling groups are a way that you can define how your systems can scale out or scale in. And I'll be talking about that a little more later when we talk about the high availability stack. One thing I think you should look at in Amazon EC2 is the savings plans and reservations. So savings plans are you can base them on compute capacity so that it's not tied to a specific instance or anything like that. It's based on across your organization. So you could do it at your parent account and it'll measure your compute usage across the entire organization, including Lambdas, containers, whatever you're using compute capacity with, this savings plan can apply to it. And it's effectively, you tell Amazon, I guarantee I'm going to use this much in compute capacity over a year. And with that, you get like a pretty significant discounts over the course of the year. So we make use of it and we've had pretty good success with it. There's also reservations. The thing you got to be aware of with reservations, you can get bigger savings, but the challenge with them is that they're tied to the region. They're generally tied to a specific region, and they're also tied usually to a set of EC2 instance types. So if you ever want to change the type of instances you're using, or you want to switch to serverless or Lambdas for different things, you'll end up actually not being able to use that same reservation for that. So that's why I usually prefer the savings plans over the actual reservations. One thing to be aware of when working with EC2 or anything else is account limits. So there's a tool called the Trusted Advisor, and you can actually use that to check if you're near any of your limits. So like if you spin up too many instances, you may get an error saying you can't spin up anymore because you've hit some arbitrary limit. And if you do get to that, you can actually talk to Amazon and they will they will actually increase it. You can request that. A couple little things with EC2. We usually use SSD for OS, and we use EFS or S3 for data, depending on what type of install it is. If you run into slow issues, it's usually a good idea to check your burst balances if you're using general purpose SSD. That's just something to point out with EC2. RDS. So what RDS is, it's effectively just a managed database service. So with most people, the easiest thing to do is you just have an all-in-one system, or maybe you have containers and you have a container that's acting as your database, or if you have everything on one server, you would have just MySQL installed and you're using it like that. With RDS, it's a way to scale your stack, and it's a way to kind of separate your database from your actual your instance. So it allows you to break it out. One good thing about RDS is that it's managed by Amazon, so you don't have to worry about updating your database server or taking care of different maintenance operations. You just set a schedule and it will actually do it for you. It can be expensive depending on what you're setting up. So normally, if you have a smaller repository, I normally would recommend just sticking with a single server or something scaled down. And if you need to scale out, then look at RDS because it can be expensive depending on what you're setting up. One way to try to control those expenses is you can use reservations in it, similar to EC2, or you could actually go to serverless. So Amazon offers serverless offerings with RDS, with Aurora in particular. So what Aurora is that it's basically Amazon's version of Postgres or MySQL. They're fully compatible. So if you're somebody who uses MySQL, you could easily make the switch. And it offers the serverless option. I usually consider it superior, like over the standard MySQL or Postgres offerings because it offers point-in-time recovery. There's multi availability zone options. And for reference, I guess I should point this out. Within Amazon, everything's separated by regions. And then within that region, there's availability zones, and each availability zone can be thought of as a data center. And for every region, you usually have at least 3 availability zones. So in some regions, there might be 5 or more. So I guess I just want to point that out there. Again, like with EC2, if you're running into performance issues and you find things are getting really laggy, it's usually a good idea to check your burst balance because it also uses SSD in a lot of cases and it can run into performance problems. Another thing is if you notice your periodic lockups with RDS and you can't figure out what the problem is, you may want to look at what your snapshotting schedule is. When Amazon takes snapshots in RDS, it can actually cause, it locks the IO and it can actually cause problems. So one way you can actually get away from that happening is setting up a standby instance, which is an option with the RDS. And what Amazon will do, it will actually take a snapshot of the standby when it's doing the snapshots and not your primary instance. And that will help save you from having IO lockup. Or you could switch to the serverless model and it doesn't have the same problem. AWS Systems Manager. So I love this tool. We make heavy use of it. It's a tool that you can use to essentially manage your servers across Amazon as well as on-premise. So you can use it to manage servers within your own university, your own data center, and Amazon. It's generally free, surprisingly, depending on what you're using in it. A lot of the things in it are actually free, or they have a very generous free tier. So for reference, I have probably 70 servers in ours at least, and it hasn't cost us anything. So I guess that's really awesome that it's so low cost. So we use it for patch management, system inventory. You can use it to run ad hoc commands on systems. You can run custom or define playbooks. SSH, you can actually use it to create SSH sessions. And we use this to provide maintenance across our servers, and we use it to gain insight into what's installed, or if we need to run different commands to try to see what people might have. Like if we're trying to see, for example, there's a particular exploit or issue going on the internet, we could get references of indicators of compromise, and we can actually like actively check all the servers all at once to say, yes, this thing doesn't exist anywhere. So it's really powerful. If you're doing anything with a lot of servers, I'd recommend checking it out. EFS. So Amazon EFS, or Elastic File System, it's basically just a serverless NFS with unlimited storage. So it works across multiple availability zones, which means it's fault tolerant, and you can mount it against multiple servers. We make heavy use of this in our Islandora 7 offerings to house the data stream store and object store. And we also use it to mount the data stream store and object store as read-only against our Islandora 2.0 instances when we're doing migrations. We have a Foxmole plugin that we use with our Islandora 8, or sorry, with the Fly system in the Islandora 8 offering, and that's how we carry out our migrations. It actually reads the object store and data stream store and ingest the content that way, like right over NFS. Or in theory, you could put it right on the disk. It doesn't have to be NFS. If you look at EFS, it looks very expensive, but if you actually enable there's an option to enable the transition to infrequent access, the costs come down drastically, especially for a large repository that doesn't have all of its content being accessed frequently. Backups for it can be a little expensive. So that's something else to keep an eye on. I usually find the backups are generally more expensive than the storage itself if you have the infrequent access enabled. With EFS, don't store Drupal directories, databases, or anything latency sensitive in it. You'll just have a bad time. It's mostly for like file storage. We also use it for auto scaling to store, if you're doing if you have like Drupal sites, it can be used for auto scaling because you can store like the files, your site's files directory in EFS and mount it across multiple containers or instances. So I mentioned backups. So with backups, we use a tool within Amazon called AWS Backups. It's great to organize across various services, including EC2 and EFS. It allows you to create backup schedules, define retention policies. You can create custom tags, and you can use those tags to easily add resources to your backup schedule. We have it set up with AWS STIS, which is another service in Amazon that allows us to send alerts to emails. I should point out with AWS Backup, if there's an option that says transition to cold storage, it's slightly misleading, especially with EFS, because it actually only applies to the deltas of your backups. It doesn't apply to your full backup, which has to stay in warm. So if you enable it, you're not going to notice. I mean, I would enable it, but you're not going to notice a huge cost savings. And the beauty with AWS Backup, as I said, it works across a lot of Amazon services. So we use it to control snapshots, EFS backups, and a lot of other services. So AWS CloudFormation, it's effectively infrastructure as code. So using JSON or YAML, you could define your Amazon resources. At DGI, we use CloudFormation to template everything from new account templates, scaffolding, security groups, instances, and our S3 bucket setup. You can execute CloudFormation various ways. You can do it through the UI or the CLI. We also have some Lambdas that we use to carry out various automations, including setting up replica buckets in the remote account, and we use it for we have Lambdas for tagging and updating. When we initially went down this road, we were putting them in line in CloudFormation. That's not a very good idea. I wouldn't recommend doing that. What we actually started doing and changed to doing was using the Amazon Serverless Application Model, or SAM, to set up the Lambda functions, and it makes a lot more sense. It's easier to reference and store the code versus having it in line in the actual CloudFormation templates. CloudWatch is, I just realized I'm going to run out of time here, so I'll have to be quick. CloudWatch is centralized monitoring. It's good. It has great metrics. You can use it to set up alarms, SNIS emails. You can use EventBridge within it to set up actions and scheduling. one thing with it is that when you install the CloudWatch agent, unless you install the CloudWatch agent, you're going to be limited in the metrics you can see in EC2 instances. Because with the EC2 instances, you can only see what's visible to Amazon. They can't actually see what's going on inside your instances. So if you need to see how much memory is running on your instance, for example, you have to set up a CloudWatch agent. I think I'm just going to have to skip ahead some of these services. I'm running out of time here. I got a little long-winded. So CloudTrail is for API-based monitoring, and it's kept for 90 days by default. AWS Config is used to record and evaluate the configurations of your Amazon resources. So you can actually use it to set up to monitor compliance, to check, okay, are your buckets publicly accessible? And you could actually have it set up with an action so it can automatically actually fix whatever's wrong, which is really neat. Amazon Guard Duty is what we use for threat intelligence. So what it does is it actually monitors our services to see if there's any sort of unusual traffic or behaviors, and it actually alerts us. It's pretty low cost. We have it enabled across our organization. It monitors everything from S3 buckets, API requests, network traffic. I'd highly recommend it. We also make use of CrowdStrike for endpoint protection, but that's a non-Amazon service. S3 storage. So to kind of go with what Mark Jordan was saying, this is our distributed S3 storage that we use with our Islandora 8 instances. So with this, all previous versions, we send them to Glacier Deep Archive. Nothing is ever deleted. We only use delete markers. Our buckets are replicated to a completely separate account that's actually outside of our AWS organization that only a couple executive level staff members can actually even access. Our replica buckets, we keep them in Glacier Deep Archive to keep the costs low. Something about S3 is it's fully redundant. It uses MD5 checks and CRC checks to detect and repair any corruption. In Islandora 2, one thing with Islandora 2, the metadata is not generally kept in files, but it's actually a part of the node in the entities. So we preserve this data by exporting it out of Drupal using a content sync, and we actually export that to the bucket as well. And we also have done worm protection, but that's optional. This is the proof of concept scalable architecture, and I'm just realizing I'm not going to have time to cover it because I'm going to cut into Morgan's time. Yeah, this is a proof of concept I did. It's multi-availability zone. I have an application load balancer fronting Drupal, and EFS was used against Drupal for the sites, the sites directory. So the shared files were in EFS. I made use of Amazon MQ instead of ActiveMQ. You notice the symbols and everything are these arrows pointing in. Those are all represent auto scaling groups. So they would actually expand and decrease if something went down, or if the CPU usage got too high, it would spin up another instance. And yeah, Solar was used with Solar Cloud and Zookeeper, which also were auto scaling and Aurora serverless. Not sure I'm going to have time to take questions directly. Is there something right after Morgan? Like if he goes a little longer, is that? They're all right after. Okay. Okay, I'll ask if anybody has any questions, maybe just ask in the Slack channel and I'll be happy to answer them. And sorry that I went a little over.